Today we talked about, these are basically systems. Really, it's equation with variables on both sides. When we look at this, we're looking at two linear situations that are being set equal to each other. When I look at this problem, Mamma Mia Pizzas sells pizzas for $8 each and charges a $4 delivery fee per order. Antonia's Pizzeria sells pizzas for $6 each and charges a delivery fee of $10 per order. For what number of pizzas will the cost of the restaurants be the same for a single order? So this equation wasn't here to begin with. I wrote this equation. And the way I wrote it was, I have $8 each and a $4 delivery fee. So 8p for the number of pizzas plus 4 equals $6 for each pizza plus a delivery of $10 per order. The reason why I set them equal is because I want to know when they are the same. So if this is the cost for a pizza at Mamma Mia's and this is the cost for Antonio's Pizza, when they're equal, that's when they're going to be the same. Okay? So that's the reason why I set them equal, and that's why this equation matches this situation. We're going to solve this just like we would any other problem. We subtract 4 from both sides. And again, the order doesn't specifically matter. This is just the order I do it in. If you want to do the other way first, I'm cool with that. 6p plus 6. Now, I'm gonna get rid of any numbers on this side. I'm going to subtract 6 from both sides, or 6p from both sides. And I get 2p equals 6. Divide both sides by 2, and I get p equals 3. So what that means is, for 3 pizzas, the costs will be the same. Now, generally, when we solve one of these problems, we don't just want to know how many pizzas. We want to explain every part of that problem. So, I can figure out how many pizzas that is by substituting that p back into this problem. 8 times 3 plus 4 equals 6 times 3 plus 10. Well, 8 times 3 is 24. 24 plus 4 is 28. 6 times 3 is 18. 18 plus 10 is 28. So when I buy 3 pizzas, I pay $28 at both places. So the way I would explain that is I would say 3 pizzas cost $28 at both restaurants. Okay? So this is the first kind of problem that we might see when we deal with equations with variables on both sides. The second kind of problem that we might see is this one. This one says Perfect Pizza sells pizzas for $7 each and charges a $4 delivery fee per order. So I have pizzas for $7 each plus a $4 delivery fee. House of Pizza also charges $7 per pizza, but has a delivery fee of $9 per order. Okay? Now Shayla's got a coupon for $5 off the cost of delivery at House of Pizza. So if she uses her coupon, what number of pizzas will she need to order for the cost of both restaurants to be the same? So both and the same tell me that I need Perfect Pizza and House of Pizza to be equal. So when I start to solve this, I notice 7p plus 4 is kind of perfect the way it is, but I've got to combine some terms over here. I have 7p plus 4 equals 7p positive 9 minus 5 is plus 4. They look exactly the same. So what I'm seeing is that once I put the coupon into play, it costs me exactly the same amount when at Perfect Pizza or House of Pizza. If I wanted to keep on going and continue to solve this problem, hey look, they still look the same. If I try to get all my p's on the same side, I have 0 equals 0. What this means is I'm seeing the same, they are equal every step of the way. This means that any time I order pizza for any number of pizzas, they're going to cost the same. When I see this, what we say is that we have infinitely many solutions. Or if you're lazy like me, you write IMS. I have heard this referred to as the identity, and the way I think about it is when I look at one of these equations, if at any point while I'm solving, the left side looks at the other side, at the right side, and sees itself, then I've got infinitely many solutions. That happens here, right here. They're exactly equal. It happens right here. and it happens right here. Every step along the way, these equations are simplifying to be exactly the same. That's why I know I've got infinitely many solutions. When you graph that, what it looks like is it looks like you have one line only graphed, because what happens is the first line graphs right on top of the second one. Okay? And really quickly, this first example that we did, what it looks like is you have two lines and they cross in exactly one place. Okay? So infinitely many solutions. When I look at the table of infinitely many solutions, what we're going to see is, whoopsie, we're going to see, so if I put in 7, well, let's clear this. 7x, remember we always use x instead of any other variable. 7p plus 4 and 7x plus 9 minus 5. When I look at the table, every single row is identical. Really quick, I'm going to fix this. Every single row is identical. So y1 and y2 are identical for every row. And when I look at the graph, like I said, oh my goodness. Well, pretend that didn't happen. I'm going to turn this off. I'm sorry. I know this is like totally a waste of your video time, but whatever. When I look at the graph, it's still graphing over there. And I only see one line because those two lines plot right on top of each other. Okay? So that's what this looks like. That's what infinitely many solutions looks like in the calculator. The last type of thing that we might see in a situation with variables on both sides is we might see this. It says Marco's Pizza charges $5 per pizza and a delivery fee of $10 for every order. Romano's Pizza charges $5 per pizza and a delivery fee of $8 per order. Right away, I see that these have the same slope, which tells me they're parallel. Okay? Well, parallel lines never touch. These two lines are never going to touch. They're never going to cross. That means they're never going to have, there's never going to be a place where they're both the same. Okay? And we want them to be the same. That's why we set them equal. And let me show you what that looks like. When I solve, I'm going to start by, again, letters, numbers. I'm going to subtract 10 from both sides. I get 5p equals 5p minus 2. Well, now when I move 5p across the equal sign, whoops. I'm going to write that because that looks crazy. O equals negative 2. Okay, well, does 0 equal negative 2? No. These are always going to be negative 2 apart. They're always going to be 2 units apart. That is not true, so I have no solution. I've had lots of kids today ask me if no solution and undefined are the same thing. No, they are not the same thing. Undefined is a vertical line. No solution means I have two parallel lines. They're running parallel. They're never going to cross. They're never going to touch. That means they will never have the same value at any y value. Okay? So when I look at this on the calculator, I see 5x plus 10, and I see 5x plus 8. When I look at the graph, I can see right away, now I can see that I have parallel lines. They're not crossing, okay? When I look at the table, 10 minus 2 is 8, 15 minus 2 is 13, 20 minus 2 is 18, 25 minus 2 is 23. Every single one of these y1 and y2s is exactly the same distance apart. They're all 2 apart. They're all going to be. I could scroll for hours and I'd never find a place where these two cross because they're not getting any closer together. That's what no solution looks like in your calculator.